What's up, everybody? This is Aaron. I'm here to drop some more knowledge on firepower threat defense, this time around managing a typical customer request. Hey, I've got a new server. Let's start serving some traffic. Here we go. Today, we're going to look at a typical ticket that a customer or change request that a customer may put in and say, hey, I need to make some changes to my firepower threat defense firewall. In this case, the webhead instance that's been created on the inside at 192.168.80.233, and it's going to be serving up traffic to the public internet on the standard HTTP and HTTPS ports. And so we've been given the task to assign a public IP address to this thing and make sure that we've got that one-to-one static NAT. We've got the access policy only allowing ports 80 and 443. Additionally, they said, hey, we only want clients to be able to reach this webhead if they're coming from a North American IP address. So some GEO-IP restrictions. We also want to apply an IPS policy to this thing. We want to make sure that we log all of the connections, and then we're going to deploy the changes. And finally, we want to be able to test the changes, and then we need to be able to communicate the changes that we made to our requester, to our customer. It could be your boss, could be a customer at work. So let's go ahead and get started. So the first thing we're going to do is get logged into this FTD. So I'll just log in with my credentials here. So the first thing you're going to want to do is make sure that there's not any changes that are pending on this device that have not yet been deployed into production. So the first thing I'm going to do is pop up here to the pending changes screen and make sure that there aren't any pending changes. So I know that I'm starting with a clean slate here, and I don't have to worry about making a bunch of changes and then realizing that, oh, there were some other changes that should have been deployed. I don't want to be responsible for those changes. So we're making sure that there's nothing here to be deployed. So there's not. So let's start by creating our NAT. Now we could go into objects first and create the objects, but this does have a nice feature in FDM that allows us to create the objects on the fly. So what I'm going to do is I'm going to pop over here to policies. I'm going to click on NAT, and I'm going to go ahead and create my first NAT rule here. So I'm going to click on create NAT rule. Now the type of NAT that I'm using is a one-to-one static NAT. It's to where I'm going to map a public IP address to an internal IP address on all ports, all protocols. So to do that, I'm going to change this to an auto NAT. And then for the source interface, that's going to be the real address of the server. So that's coming from my inside segment. So I'm going to dial into my sub interface here, my inside sub interface that happens to be under gig 01. Select it. For the destination, I'm going to have to NAT it to the outside world to a public IP address. So I'm going to click on outside. So we're halfway there. Now, the next thing we need to do is just identify the objects or create the objects that represent the actual IP addresses of both the actual IP address, the real IP of the server, and then the NATed IP of the public IP address that we want to assign to it. So under original address, I could look through here to see if I have one, but I happen to know that I don't already have this one assigned. So I'm going to go ahead and click Create New Network, and it's going to open up an Add Network Object screen where I'm allowed to give it a name, like Web1, private maybe. Now, the reason I'm keeping that fairly generic is the whole point of objects is that we can change their value later and not have to worry about changing it throughout the entire configuration. So I'm keeping it somewhat generic there. Maybe 192.168.80.233 is what I was told in my ticket that the server was assigned. So I'll go ahead and make that a host and give it that specific host IP address. If you want to give it an IP address, you can. You can say web1 created in ticket 123456, right? If you want to put some kind of documentation on how and where this was created. So we'll go ahead and create that object. And now you'll notice it's not highlighted, but we can now filter on that and just look for that web1 object that we just created. So now we've got the real IP address associated with the source interface of inside. Let's jump to the destination and assign it. Now, by default, it's going to say, hey, let's path this thing to an outside PAT, but we don't want a PAT, we want a NAT. So I need to create that object for that IP address. And so again, I don't have that object created yet, so I'll create that new object. I'm going to call this one web1 public, and then create a host address, and then we'll grab that IP address that we were told that we were assigned for this machine. So we'll go ahead and put that in there. Hit OK. And now we'll just go ahead again. We can filter on our new object by looking for web. And now this time we want web public because this is the NATed address, not the private address. So I think that's all we need. It's been enabled. Oh, we need to give it a name. We forgot that. So I'm just going to say NAT web1. And I'm going to put dash 233. the last 3 digits of the private address for whatever reason. Because you could have more than one NAT pointing to Web 1. So we've got our first NAT address pointing to Web 1 here, and we're off to the races. I'm going to hit OK. Now, if all went well, the GUI then makes that API call to the machine to stage that change. And you'll notice that the icon for pending changes has now got a little orange dot in front of it, indicating that we've made some changes. So now we're ready to deploy that thing. But before we do that, let's go ahead and take care of our other things, right? Our other objects or our other requirements from this ticket. So that's just the first requirement, give it a public IP address. The next requirement is we want an access policy that allows traffic on 80 and 443. Well, that's easy enough. We're going to go over to, again, policies, access control. I like to make sure that there's not already a policy allowing 80 and 443 maybe globally. In this case, it's very easy to see. I only have 3 rules, and I don't have anything that looks even close to that, right? So I'm going to go ahead and create my new rule by clicking on the plus sign over here. I'm going to give it a name. Let's call this Web 1 public access 80.443. All right, kind of describe in the name of the rule what it does. By default, it's going to add it to the end of the access control policy. Now, let's start with the source zone. The source zone, it's going to be coming from the outside. We want to serve this to the outside world, and it's going to be arriving internally on the inside interface. So that's easy enough, or in the inside zone, which is also associated with the inside interface. Now, for networks, we know that we need to allow the entire world to it, right? Well, wait a minute. You said that we can only allow North America. Well, okay, you're right. We can only allow North America. Let's back that out. We don't allow any IP address. Remember, one of our requirements were that we only allow North American IP addresses. So instead of putting an IP address object here in the networks section for the source address, I'm going to put geolocation. So if I click on geolocation, it'll give me all the continents. And then within those continents, I have the ability to dial in and actually select individual countries. But in this case, the requirement was all of North America. So rather than just select, let's say, a particular country in North America, like Aruba, one of my favorite vacation destinations, instead of just selecting that and going through and selecting each country individually, we can actually just click on the North American continent and inclusively include all those countries underneath it. So they're all included by default there. So we've solved for that requirement. We now have only North American IP addresses can source this traffic. Well, where are they going to? Well, we know that they're going to go to Web 1. And now this kind of has an ASA on the back end. They call it the Lena engine, which is basically the ASA source code. And as you know from ASA, as of post 8.3, that when you create an access control list entry, you need to use the real IP address of the server, not the NATed IP address of the server. So the object we want to select is the Web 1 private IP address. And then finally, the ports and protocols that we want to allow, again, the requirements were HTTP and HTTPS. So now we've met all those requirements. And you'll notice immediately that on an ASA, you would have had to create 2 rules or done some kind of a port range or something. Here you can just select as many ports and protocols as you wish, and HTTP, HTTPS already built in. So we've met all of the layer 4 requirements plus the layer 7 requirement of only allowing North American IP addresses. So I think we've met most of these requirements. So let's move on to the next one. Now it says we need to apply the balance, security, and connectivity IPS policy to this rule. So that way, in the FTD, you can apply IPS policies on a per rule basis. And so we need to make sure that we apply the IPS policy here. We do that here by clicking on intrusion policy, hitting the radio button to switch it on. And then the policy that we use is balance, security, and connectivity, which is a pretty good balance of just what it says, security and connectivity, right? And it also makes the best use of system resources by not loading too many IPS signatures into the system. So that way we just scan, the really credible threats out there. So that's it. That's all there is to turning that on for that rule. We just dial the radio button and select the policy. And so we've got everything set now. Now let's see if we've got any more requirements. We got one more requirement, don't we? Make sure that all connections matching this rule are being logged according to best practice. Well, Cisco says best practice when you're recording a rule for an access policy where you're permitting the traffic is going to be logging at the end of the connection. So we find that setting here under the logging tab. That makes sense, right? If we click on logging, you'll see by default there's no connection logging, but our requirement is to do a connection logging at the end of the connection. So I'm clicking end of connection. And then where do we want to send those to? Well, now we get to pick which syslog server we'd like to send those events to. So I have this 10.0 server sitting out there where I'm going to send all of my syslog or all of my connection events coming from this device to that syslog server. So that's it. I think we've met all of our requirements. Let's double check. Coming from the outside to the inside, coming from any IP address sourcing, originating from North America, going to Web 1, to the private address of Web 1, but only on the HTTP and HTTPS protocols. We have applied our IPS policy for balanced security and connectivity, and we have enabled logging per best practice to say log at the end of connection. I think we've got everything set, pointing to our syslog server. Oh, by the way, we've got our action set to allow, which is the intent and the default when you create a new rule. I think we're all set. So I'm going to hit OK. If we did everything well, it's now sending a API call to the FTD box where it's now created that rule and staged it for deployment. And here we see our rule, and it sure looks exactly like we said. The little alien with the shield on it's lit up because it knows that, hey, you've applied an IPS policy, and it looks like everything's all set to go. So I think we're ready. That's been a lot of talking, but let's just take a quick look here at our changes. Now, the next requirement, by the way, was deploy the changes, test and make sure that the changes worked as intended. Okay, so we'll do that in just a moment. But before we do that, I want to take a note at point number 8 here. Communicate the changes to the change requester, including the test case results. So how are we going to communicate the changes that I made in a GUI, right? That sounds kind of difficult, and it is kind of difficult to do in a GUI. But what we'll do is, FTD's thought of this for us. Actually, the FDM team has come up with this for us, and they designed a way for us to be able to do that. If we go to our pending changes screen, down here in the lower left-hand corner under more actions, one of the options you'll see is download as text or copy to clipboard. And what it'll do is it'll take all these changes that are currently staged to be deployed. And by the way, it's nice that it gives us a visual education indication that it's what is going to be deployed. All that's here. So now all we do is we just simply hit download as text, or we can copy to the clipboard. I'm going to go ahead and click download. And I'm going to open it with my text editor. And you can actually see all the changes that we're about to make. So it tells you all the objects we're going to create. It's in a YAML format. So if you're a code person, that should really be exciting to you, because now you can do some things with that YAML. But now I can copy this and paste it to a ticket. Or I can communicate it to a customer in an email, or whatever the method is that you have for your change request system. So now I've got that downloaded. We're good to go. I'm going to go ahead and deploy that. So we'll hit deploy. We'll see the deployment job is now in the queue. If you're curious to see what's currently running, you can change this screen without losing anything. And we can pop over here to the task list. Just like on your Windows Task Manager, this will show you the tasks that are currently running or pending or happening on the machine. So you've got an idea of what your machine's doing right now. While we're waiting for the deployment to finish, what we can do is get ready for the testing phase, right? That was one of our requirements, was we need to test this connectivity to make sure that our intended rule is working as we think it should, right? So to do that, we're going to go over here to the command line window. The command line window is a way to give us a little CIL console that allows us to issue commands to the CLI without having to go SSH into the device. So Packet Tracer is probably going to be the best way to test our rule without having to actually send traffic from the data plane. So this will generate a packet and send it through the data plane engine for us and show us exactly how the machine is thinking, right? So we're going to run Packet Tracer inputs from the outside interface. We're going to send it a TCP packet, as HTTP and HTTPSs want to use. We'll source it from the IP address of 8.8.8.8, a North American IP that belongs to Google, I believe, with an ephemeral port of 1099. Just picked one out of the air there. Now we're going to send it to our destination IP, our public IP address from the outside. So that's going to be this 203.113.15. So 203.0.1.15, that would help, right? And let's send our first packet out on port 80. Our changes have deployed. So let's go ahead and fire off that test packet using Packet Tracer and see what happens. Packet Tracer says, let's see, it starts here, it unnats it, so it looks like our NAT's working properly. It matched on that NAT, on the Web 1 public NAT that we saw, right? And it untranslated it from this public IP address 203.0.113.15 to 192.168.80.233. So far, so good, right? Now it hits this access list. Now be careful with this access list allow statement, because had this been an IP address from, say, Europe or South America, this still would have showed an allow at layer 4, because this is not where the GEO-IP is being assessed, right? So be careful with this one. So yes, it passed the access control policy, but we're not done yet, right? The next thing we're going to see is it goes down here and starts to create the flow. But then at phase 10 here, you see that it gets passed to the snort engine. Now this is where the GEO-IP would come into play and say thumbs up or thumbs down on this IP address sourcing from North America, right? In this case, it is sourcing from North America. You'll see here that it matched to zone 2, 1, GEO-840.0, which probably means a lot to a Cisco engineer somewhere. But to me, it just means that it did find a match for this IP address in the GEO-IP database, and the snort verdict was allow. So this must have been from North America. And then finally, it's going to try to route it to its destination. It finds the egress interface inside just fine. However, at the end here, you're going to see, well, it failed because it can't find a layer 2 adjacency. That's because I don't really have a server listening right now on layer 2 in the inside segment. Had I had that up and running, it would have been just fine, because it said, hey, we would have been able to find an ARP for that, but it can't ARP for it because it doesn't exist out there. But all in all, this just means that our rule worked exactly as it was designed to work. Hey gang, that'll do it for this episode. I hope you got something out of it. I'm Aaron, and I will see you next time.